This is a quick video to compare taking an integral with a u substitution versus taking one with integration by parts. Sometimes it's not always obvious what it is that you have to do. Now obviously I'm doing problems that are geared toward the AP test, and integration by parts isn't a huge part of the test, but you do need to know how to do it. So let's have a look at this one. When I look here at this one, what I see is this. I see x and I see the 5x squared term. And I realize that if I take the derivative of 5x squared, I don't get x, but I do get a linear function that has an x in it. So that kind of screams out to me. In other words, like, this piece right here is pretty much the derivative of this piece right here, which screams out u substitution. So I think by now you should be okay with the fact that I'm going to let u be equal to 5x squared, and that's going to force du into being 10x dx. So the way I make my substitution is I say, okay, well, my integral, I'm going to just pull the 1/7 out front. That doesn't need to be in there. So the things are, and this is like a permeable membrane to a constant. So the things that are still in there are x is still in there, and then I have e to the 5x squared dx, and this is before I make my substitution. Now to make this work, I want to replace all of this stuff with du, but I need this to be down here, and currently it isn't. I have the x, but I need the 10x to be in front of it, so I'm going to put the 10 in, which means out front I'm going to multiply by a 1/10. So now I can make the substitution and everything is accounted for. So out front what I have is 1/70 integral. Now this stuff right here gets absorbed into du, so that becomes du. And then I'm left with e to the u, because this is just u. So now the whole point of the u substitution is that I got an antiderivative that's very easy to take. So my answer to this question is going to be 1/70 times e to the u plus c. Now technically I guess the c should be in the parentheses and it gets multiplied by 1/70, but it doesn't matter because it's going to be plus c. It's going to be some other constant, so I put it out here. But you end up with 1/70 e. Now I put u back in with what it is, 5x squared plus a constant. And it's not too hard to see that if you differentiate this, you're going to get back the original function. Now let's compare that to the integral of e to the 5x, x e to the 5x. So now what we're looking at is this. We're looking at the integral of e to the 5x, but now it's just times x dx. And let me just scroll the screen up a little bit. And now it's no longer a u substitution, or at least it's not anything I can see as being a u substitution. So now we go back to integration by parts, and if you haven't seen the first video, see the first video on this topic. So here we go. We've got this. We're going to let u be equal to x, and we're going to let dv be equal to e to the 5x dx. Now you might be saying, how do you know what to let u equal to and what to let dv be equal to? And there's a couple of rules of thumbs, but there is no definitive way to decide. The way I pick it is I pick dv to be the most complicated part of the integral that I can still integrate relatively easily. So technically this is a u substitution, so I'm going to do it as a u substitution just for the practice. So if I'm looking for du, very easy to find, that's just 1 dx, so that's simple. But to do this as a u substitution, it would be you let u be equal to 5x, which means du is going to be equal to 5 dx. So to make this work, I'd have to put a 5 in there and a 1/5 out front. Haven't changed anything, and now that would become u. So I think it's fairly clear that v is going to be 1/5 e to the 5x. And differentiate it, and you can see that you're going to get back what you started with. So let me just scribble that out so I don't confuse myself. So here we go. It's going to be, the formula says this, I got to do uv minus the integral of v du. So let's see what we have. This times this is going to be 1/5 e to the 5x times x minus the integral of b 1/5 e to the 5x du, which is just dx. So now I think I've been successful in that I've taken a complicated integral and I've reduced it into a problem like this minus a fairly easy integral to take. So to finish this off, this is going to be 1/5 x, e to the 5x minus 1/5 the integral of e to the 5x dx, where this is now basically a u substitution. So u is equal to 5x, du is equal to 5 dx. So to make it, I need a 5 there, and I need another 1/5 out front. So this becomes 1/5 x e to the 5x minus 1/25 antiderivative of e to the u du. I might be overdoing it a little bit with the u substitution, but I just want you to get to practice at it. Let me scroll this up a little bit. And now we have final answer 1/5x e to the 5x minus 1/25 e to the u, which I'll just plug the u back in right now, is going to be e to the 5x plus constant. And you can check for yourself that when you differentiate that, you will get back the original problem after you reduce it. Okay, so here's another example of an integration by parts, and I also threw the other u substitution in there just for good measure.